Welcome to another tutorial of MapCuba. In this video we are going to explain the main tools that can be used for data reduction using this software. The first thing we need to know is that the spectra container always loads the data into a MapCuba product that in turn generates automatically a MapCuba subproduct inside the parent one, named original. Inside this subproduct we have the data we are using in this example. This is from a survey of massive star-forming regions and was imported from the IRAM radio telescope in a previous video. They were taken in 4 bands, 2 adjacent at 2 mm and the other 2 also adjacent at 3 mm. Because of the properties of our data, we first may want to separate them by regions. This is achieved easily by clicking on the heading parameter object. We see that now we have all the spectra organized. If we select all the observation of one region and right-click on it, we see that we have a few self-explanatory options. So, in order to separate them, we click on Copy, Select to and New tab. This generates a new subproduct with our data selected in it. We can change the name of this tab by right-clicking in the header, just like we are showing. Now we can save it by clicking in the Save button. Here we are choosing Save Selected Spectra. Note that this option only saves the tab selected in blue, while the All subtab option saves all of them. Now that we have one region separated and saved, the same procedure can be applied to the other ones to start the reduction of them. The different tools available can be accessed by right-clicking on the plot. Here we are going to give a brief explanation on a few important ones, which are average, baseline, or smoothing. We can easily apply average on the data we plot. In the example, we saw 2 spectra in the same frequency window. If we right-click on the plot and then click on average, we see that a new window shows up with multiple options. Weights is employed to modify the weighting of the spectra to compute the average. Equal will give the same weighting to all of them, while sigma will give more importance to the spectra based on their root mean square. Clicking on View shows the aspect of the average spectrum in light green, while Clear will make it disappear. Pressing on the Apply button generates another tab with the name Average that has the average spectrum we have done. The Baseline tool can be accessed by right-clicking in the plot spectrum and clicking on the Baseline option. The first thing that we need to be aware of is whether we are subtracting a baseline in the whole spectrum or only what we are showing in the display. Likewise, if we are displaying the whole spectrum in the plot, both options will be doing the same. Before subtracting a baseline, we need to select the polynomial-free windows. They are selected by clicking the left button while holding the Shift key on the starting and ending of the desired region. A reminder of this shortcut is written above the spectral units option. Note that the blue line indicates the zone of each window with their values in the baseline window. They can also be entered by checking the user value box and typing them manually. Once we have selected all of them, we can click on Fit to see how accurate our baseline is. Note that this fit can be changed up to a 10th degree polynomial. In this example, we are going to leave it at 0. If the tab baseline box is checked, a new tab will be generated when Apply is clicked, which is the same as with the average option. Note that if we uncheck the box, the changes will be applied on the tab we are working on, as we can see on the plot. Once it is applied, we see that the RMS of the spectrum is written in the Information MapCuba window. Smoothing is used to degrade velocity or frequency resolution of the selected spectrum. Like baseline or average, it can be accessed by right-clicking on the plot. Among the information that shows up, the channel separation indicates the resolution of the spectrum in accordance with the unit selected right above. The desired resolution is written in the box size box. In this example, we are choosing a resolution of 1 km per second. The Clear View Apply procedure operates equally as in average or baseline. Therefore, clicking on View allows us to see the changes done and how the spectrum looks like in light green. Alternatively, clear will remove it, and apply will implement the changes in the same subproduct or in a new one called smoothing, whether we have the tag box checked or unchecked. In this example, we are going to apply it directly on this subproduct. It is sometimes useful to see the changes we did in the spectra. This can be checked in the header parameter version. For instance, in this example, we can see that we have applied one time average, one time baseline, and another time smoothing. All in all, we stress that this is just a brief introduction to give new users an easier adaptation to the software, and therefore, we cannot cover all the options available. For particular or more advanced analysis, we refer the interested ones to the documentation of the software. Alternatively, you are always welcome to email us in case you did not understand some steps or want to do something not covered here. Thanks for watching.